Hello, everyone at MTL Connect. On the last day of the event this week, I'm very pleased to introduce you to Eric Neves, the co-founder and CEO of Plus One Robotic, a company specialized in 3D and AI vision assisted robot. And his slogan is robot works, human rule. So it will not be the future of Terminator that he will talk about today. So today, Eric will talk to us about the relationship between robotics and e-commerce. Eric, all yours.
Thank you very much, and greetings from the Port of San Antonio here in Texas. And we're pleased to be able to join you today to talk about the growth in automation for warehouses as a result of this e-commerce push. There is $100 billion in warehouse labor south of the border here in the United States. And that warehouse labor continues to grow faster than the rest of the economy. And we'll talk about why that might be. But there are systemic problems in the labor market for warehouse. Most notably, apart from just the gross dollars of the warehouse labor, it's the churn. These are not desirable tasks for people to be doing. So any given role within a warehouse often churns no fewer than 3 times per year. So imagine if you had your workforce in a factory turn over 3 times every year, it would be nearly impossible to be productive. In the warehouse, it is still possible because these tasks are simple, but the churn is very high. So also, they have a limited pool of talent from which to draw from. And the reason for this is something that's specific to warehousing, which is if you build a distribution center or a fulfillment center or a parcel hub, you're going to build it somewhere. Chances are you're going to be right across the street from another one and down the block from a third, et cetera, because all warehouse and supply chain companies are working from the same constraints. They need access to infrastructure. They need zoning. They have to meet zoning requirements. And so you end up with this sort of congregation of warehouses. And what that means is they're all drawing from the same pool of labor. This is what has led to the growth in warehouse wages outstripping the rest of the economy because it's easy to cross the street for an additional $1 an hour. Also, it is difficult to grow the staff to meet peak demand. Now, this was more true pre-COVID. Pre-COVID, you had warehouses sort of run at a steady state for 9 or 9.5 months of year, and then they would peak very high during the holiday surge, or what they call peak season. Well, COVID has accelerated the adoption of e-commerce all year long. So now what used to be a 3-month peak season is now longer than that. Even so, as we like to say in the warehouse world, it's hard to build the church for Easter Sunday. You can't build the outfit entirely for peak demand because then it's going to lie fallow too much of the time. And then, of course, it's hard to attract talent because these are not desirable roles. 6,400 parcels per second by the year 2023. And that's driven mostly by as the consumers, continued adoption of e-com as our preferred method. 100 million parcels per day by 2023 means you have a lot of repetitive motion injuries in the facility. This is what that really looks like. So this is FedEx in Memphis, and this happens every single day. You have this river of parcels and an army of people, and their job is to take all of those parcels from the left and put them on the conveyors behind them. Notice the fans. This is unair conditioned and unheated space. So during the winters, it's cold, and during the summers, it is hot. So this again contributes to the churn in these kinds of roles. And now I'll show you what this looks like on a global scale. This is from China. I will spare you what it looks like on Singles Day in China. It's nearly overwhelming. But what it means is there are lots and lots of opportunities to bring automation to support the lack of labor that the warehouses are enduring. This kind of gives you a sense of the workflow of a given order. So from the time you hit click on your favorite shopping site, you now spin up a whole series of activity, right? So up at the top, imagine the goods are coming in from some port somewhere, and we all know all the supply chain problems at the ports today. But the goods are going to show up at a e-commerce house, and what's going to happen is you're going to unload the truck of all these parcels. What happens next is you unpack all of these bulk parcels and you turn them into eaches. Eaches is the term for individual items. And those eaches are unpacked, they're barcode scanned, and they're placed into storage. Now you hit click on your website, and what you spin up, turning those eaches into new parcels. So the eaches come off the shelf, somebody pulls your order, packs it into a shippable, a carton or a mailer or what have you, and now it is a parcel that gets placed and sorted and ultimately loaded on the outbound truck. So you can think of an e-commerce fulfillment center as really just a parcel redistribution operation. Big parcels come in on the left, little parcels go out on the right. Once it leaves the e-commerce center, now you're at your parcel shippers. So this is the Postal Service, Royal Mail, UPS, DHL, FedEx, etc. They unload parcels, they sort them, load them again, and then it goes to another part of the hub and spoke, unload, sort, load, and this may happen 2 or 3 times before it gets to last mile. There's, of course, a lot of famous automation happening in the last mile with drones and all of that. But just look at everything that happened before. There are no fewer than 22 touches of labor for every time you hit click on a website. What that means is everyone is needing robots to come supplement the labor. There's not enough. What are the applications that they're looking for? They're looking for picking, meaning robots to take things off shelves or out of totes, palletizing, building a pallet to be shipped out of the facility, depalletizing, meaning reversing that process when it gets to the next part of the network, and then finally, mobile collaborative robots, or what are often called AMRs. And AMRs are mobile robots that drive through the facility to facilitate transport within the warehouse. In the warehouse, this is where warehouse automation is different than manufacturing automation. Manufacturing is predicated on repeatability. I need to do the same thing the same way for the next however long. And if, as most robots are in the automotive industry, you have to do the same thing the same way for at least the next 4 years. But the warehouse is not predicated on repeatability. It's predicated on variability. We don't know what's going to come down the line next, and we certainly don't know what you're going to order next week. So in this case, when variability is the rule, you must perceive the environment in real time. And that's why all robots in warehouses, whether they're mobile or manipulators, require 3D vision. And we argue also requires a human in the loop. So you need 3D vision to discern where the item is and to determine that you processed it or placed it correctly. Did it fit in the outbound tote the way that you expected? Did you stack it right, etc.? But you also need a human in the loop, because a 3D vision system is based on AI. And AI is a wonderful tool. We use it every day, but AI in the face of this amount of variability will disappoint you. So you have a human in the loop, because if it's a new item that the robot has never seen before, how does the robot get running again? So, at +1, the way we think about this is vision, meaning pick one, that's what we call our vision system, and yonder, this sort of human in the loop cloud service. So imagine the robot is picking and placing, and we have some implementation examples here, whether they're each picking is dealing with the individual items themselves, usually from one inbound order to an outbound order, or induction, which is what you saw in the parcel world, or depalletizing. All of these are really just manifestations in the warehouse of the same fundamental core technology, which is 3D vision applied to industrial robots. So that's what pick one does. And it uses a 2D camera, it uses 3D vision, it uses AI, and all three of these technologies are in a race, and for every image, and whichever one crosses the confidence threshold first is what we go with. So sometimes it'll be a 3D pick, sometimes it will have been an AI that determined what the pick was, etc. But all of them have to, one of them at least has to pass a confidence threshold for the robot to automatically go pick. But what happens when none of them achieve confidence threshold? Well, that means that the robot was confused by what it saw. And when that happens, yonder, or a human in the loop, takes over. So the human is remote. So imagine the robots are all over the country and the humans are in Texas, and every once in a while, a person gets a notification from a robot somewhere in the world, sees what the robot is experiencing, and says, wow, I can see how that's a problem. Let me help you. And you command the robot from remote. Usually that's enough to get the robot going, and you may not hear from that robot again for some length of time. And this human being, or what we call a crew chief, some people call them robot wranglers or robot Sherpas or what have you, but we call them crew chiefs. They support, 20, 30, 50 robots at a time in the world. And this is what that looks like in production today. You'll see you saw the view of the software, how the robot 3D vision system interprets the world. So, kind of what's the approach? If you're going to be successful in bringing automation to the warehouse, it's got to be fast, because there's just a lot of volume that needs to push through the warehouse, and increasingly so as we move more and more of our commerce online. It has to be hardware agnostic. There's lots of different types of robots, lots of different types of applications, lots of different types of grippers that you're going to have to use. So it's got to be hardware agnostic, and it has to be a human in the loop, or it will not run 100% of the time. And you want to be doing that, with a team that's got a lot of experience. This is McKinsey's view of the world of warehouse automation. So these are all the different sort of technologies that you will find being piloted or tested by lots of different folks in the space. And you can see that it moves adoption rate on the vertical scale, and then sort of the move through time on the right scale, left to right. So most folks are still in the innovation has been developed, but they're just now starting to use it in pilot applications. There are very few instances of applications of robots in a warehouse that have moved beyond pilots. And, parcel induction is one of them, simply because there's so much demand for that task that it was one of the first ones to get automated. Obviously, there's a sort of sequence of things that you have to continue to develop to meet the needs of the warehouse. Depalletizing is one, simply because we're moving more and more of our groceries into home delivery or curbside pickup, which means every grocery store is going to end up as a micro fulfillment center. There's a lot of depalletizing associated with that. In the applications that you saw, the robot picked and just placed on the outbound conveyor, and it is later that it gets sorted. Well, there are applications where that doesn't work. The robot needs to do the sorting itself. So that means you have to have the robot pick and barcode scan. So the sort of marriage of 3D vision and barcode scanning is another piece. And then finally, container loading and unloading. This is the holy grail of the warehouse automation space, is loading the truck, because it's like playing Tetris in 3D in real time. The trucks are not insulated. It's hot when it's hot and it's cold when it's cold. This is the highest churn application in the warehouse every day. So, we need to bring automation as a tool to support that work, but it requires technologies that yet do not exist. Specifically, the Tetris part. How do you, what they call, cube out the truck to ensure you're shipping as much density in that truck as possible? People are very good at doing this intuitively. Algorithms have yet to arrive at that. And that is Plus One Robotics and how we view warehouse automation and why we believe this is such an important new market for robotics. Again, we subscribe to the notion that the humans are not just a necessary component, they are the essential building block around whom you build the solution, which is, as was referred to earlier, our motto of robots work, people rule. Thanks for your interest.
Wow, that was quite something. Eric is very instructive, and I really like your visual of the hectic environment and
Yes.
Probably a lot of warehouse right now. And I can see with Quick One and your technology, we're moving toward a more calmer place. But in your example, what popped up to mind right away, you have with Yonder, you have a Sherpa managing robots. So that will probably imply a connection to the cloud.
Yes.
So what happened if we lose access to internet? Like even we saw with Facebook, like one day there was a glitch in their software. So I'm assuming that you must have a contingency plan or something. So how do you manage these sort of risk?
Yes. So we have a saying that there is no IoT without a secure IoT, right? Mm-hmm. And certainly there's the famous case of Stuxnet, which I would encourage your readers to go learn about, because it's an example of, when it was having a cloud connection be a bad thing. It turned out to be a good thing in geopolitical terms, but regardless, the human in the loop does require that connectivity. Granted, most of the time, the robot is running independently, and that happens at the edge. Meaning, in the case of some of our applications, they run 99.6% of the time autonomously. It's that 0.5% where they go, whoa, I need help. So think of it as a high frequency loop locally and a low frequency loop remotely, right? So what that means is, if you had an occasion where you ended up having an air gap around the facility, 99% of the time you'd still be okay, right? But that does not take away from the sort of reticence of the users to allow a connection. So what that means in practical terms is often we will not be on their network. We will have a separate network, you know, a separate Wi-Fi or a separate, 3G setup specifically for the crew chiefs and those robots, and they never touch the data of the customer, right?
I see.
For another, the visuals of the packages themselves. You know, we would not want a situation where somebody from the outside could read a label of a client's purchase. So we actually have to detune the vision system so that it actually cannot read personal information.
Okay. You were showing earlier, I think, the Gartner's chart of the adoption.
Yes.
And I'm a bit stunned because I saw you were like much later in the curve. And I'm a bit surprised because I will have assumed that nowadays it's almost a given. You know, if you want to stay in business, you need to move through automation. How can you explain that, Eric?
Yes. So we have to remember that the warehouse is a legacy industry, right? These facilities have been in place for 40 or 50 years, and they are very technology reticent. The most sophisticated piece of equipment they may have in the building is a conveyor with a PLC. And you're going to come to them with robots now? They don't have the sort of requisite capacity to absorb that technology. Frankly, that's the reason I spend so much time talking about workforce development. And that's frankly the reason Montreal wouldn't have this issue, because some of the best roboticists I've ever known are from Quebec and from Montreal, right? You have ETS, and Laval. So, but yes, the adoption rate of warehouse automation today is still low. What is true, Claude, is mobile robots in the warehouse is accelerating ahead of picking robots in the warehouse. That's true. And that was driven largely by Amazon's early work with Kiva. So they acquired a mobile robot company, and today there are 350,000 mobile robots at Amazon moving shelves of goods through their facilities.
Actually, you mentioned Amazon, and I've seen some video of all these almost R2D2 robots in the warehouse of Amazon running all around.
Yes.
So are you working with these mobile robots at Plus One Robotic? Because what I've seen is, a static robot but what is your take on the mobile robots?
Yes.
In the
warehouse? Every warehouse workflow is some combination of mobility, forklifts or pushing a dolly or hauling a, cart around, manipulation, people with stuff in their hands, whether they're loading shelves or filling orders or taping boxes or something, and storage in between, either storage or, some sort of sortation machine. So today, most instances are like you pointed out, the Amazon robots moving the shelves around, and they go to fixed locations where people are pulling the items off the shelves. Well, certainly you can imagine a scenario where a mobile robot would bring a set of goods to a picking robot, and then the picking robot would do that, and then the mobile robot would drive away. So I'm pleased to announce that just this week, we announced a collaboration with a company called Locus Robotics, which is a mobile robot company, to collaborate their mobile technology with our picking technology to do the type of workflows that you are referencing.
Excellent. Nice to hear that. And one thing that surprised me when I went through your website and all that is you seem to be, I think, using ROS, robotic operating system. And I was surprised because for me, open source is not a distinctive features for a company,
Yes.
So I was wondering, because I saw your technology 3D and I said, okay, how can you build a USP, unique selling proposition, when you use open source? So I say, I will go in my garage, build a robot, download ROS, and then that's it. So I'm
Yeah,
sure it's not that simple, Eric, but
sure.
can you
But
tell me
no,
more about that?
yeah. So, the Ross framework was born from this notion of, hey, can we all just stop inventing the core part of robots so that we can start innovating on the applications themselves, right?
Mm-hmm.
And my co-founders, Paul and Sean, were the ones responsible for the Ross Industrial Initiative.
Okay.
So, yes, we are very Ross centric, and we continue to contribute to the open source community through that. But if your value proposition was going to be the navigation of your robot from A to B, that's not value anyway, right? It really is, you have to think in terms of what's the customer trying to accomplish? Well, the customer is trying to accomplish three things. I can tell you, every warehouse operator only thinks in terms of three dimensions: volume through the building, right? They're increasing throughput; accuracy, making sure the right package gets to the right destination; and uptime, meaning because I have to hit cutoff windows. The plane leaves at 3:05, whether the package is on it or not. So those are the dimensions that we focus our attention on. And the rest of that, if it happens to be an open source plugin element, great. But what you find really practically is the open source libraries for 3D vision will only get you so far. And then you have to build your proprietary know-how on top of that. And that's true all through the robotics landscape today.
And I come back to one comment you made earlier about the warehouse and their legacy infrastructure.
Yes.
Because we all know it is very expensive to move one day from legacy to
Yes.
the new system.
Yes.
So what is your advice for companies or warehouse that want to migrate maybe gradually
Yes.
toward implementing automation like you're able to do?
Yeah, so this is the whole brownfield versus greenfield argument, right? So the truth is most warehouses are brownfields, and you don't have the option of doing a greenfield. You're going to have to go find a new place, put a new building up, and reprocess the entire line to be much more automatable, right? Designed for automation and such. That would be lovely if we could do that. The instances of being able to do that are few. Amazon obviously leads that list because they're always building new fulfillment centers and sortation centers across the globe. But everybody else is a brownfield installation, which means you must be an incrementalist, right? And that actually lends itself to the way that these reticent, warehouse operators want to work anyway. They don't trust a fully disruptive new way of doing the job. They are just saying, hey, what can I do to go 15% faster? How do I get another, this much volume through the building? So yes, we subscribe to an incremental approach, the crawl, walk, run view of automation in the warehouse. So people talk about low-hanging fruit and all that, but really it is understanding what the drivers are. What are the targets for your volume for next year? Is it possible in this building at all? Okay. If it is, what are the steps it's going to take to do that? How many of those steps can the robot folks to contribute to? Not all of them. And how many are going to be done, other ways, right? So.
Very, very interesting. Maybe a last question before we leave is this year the central theme is Renaissance. So I want to ask you, in the perspective of the future, what is your vision?
Yes.
I would say of the future plus one day, or tomorrow plus one day, in the near term and maybe a longer term about automation and your vision of robotics.
There's an argument to be made that the world is, that AI is going to solve everything for us and we can all just go home, leave the warehouse to the robots and we can all leave. I actually don't subscribe to this view of the world. I believe that automation is to serve us as the people. And so I continue to take a human-centric view of automation. And I don't do that because, I'm somehow more charitable than somebody else is, but it truly is, I think, the best engineering way to deal with the problem. As good engineers, our rule should be chop the problem in half and then chop the problem in half again, right? And the way to do that is to have humans in the loop. Remember this, no robot is ever smart enough to fire itself, right? Only humans are smart enough to go, that robot is fired because we no longer need that task, right? So humans rule, robots work, people rule.
That was a brilliant talk, Eric, very much. It was a very interesting conversation. And I would like to thank you from MTL Connect. And everyone, this was Eric Neves, CEO and founders of Plus One Robotics, based in the Port San Antonio ecosystem. Thank you, Eric.
Thank you so much, all. Bye-bye.